Okay, you guys are doing okay?
You did better. I got a good grade on the test.
I'll give you the exam toward the end. The last 20 minutes we'll talk about the exam. The last 10 minutes.
Good, better.
Was that? Well, we'll figure it out pretty soon.
It's bad. It's really bad.
Okay, so I just wanted to make this matter of survey. How many hours did you study? I know you were studying. Austin was studying. But how many hours? Did you count how many hours before the exam? I'm not talking about other time.
I was studying for like a week before the test.
4 hours?
Way more than that.
And you guys went over all the homework problems? How many of you could say that I did 100% of all the homework problems?
Like 95.
Now, remember what I said at the first class was that you are supposed to do your homework problems 3 times. Okay, one is when I assign the homeworks, you're supposed to do them right away. Another time you do your homework is before the quiz, and you do it one more time before the exam, right? And if you had done that practice, there is no way the exams are going to be bad. But if you didn't do that, sometimes it doesn't work out. Okay, so we'll see what the exam scores are at the end. But definitely, I have to give you some extra credit quizzes. Okay, so I'll discuss a little bit more toward the last 10 minutes. Okay. Now remember, I gave you a handout, right? I gave you a handout from section 10.2. That was my handwritten problem. That's the take-home quiz, right? You're supposed to give it back to me on Friday. On Friday, I am going to give you another quiz, okay? And the other quiz will be on what I am handing out right now. So you might want to write on top of it that one of the problems in this handout will be on the quiz on Friday. Okay? So this handout is on arc length. I gave you some problems on arc length before, right? However, I added a few more problems here because the handout that I gave you last time, it didn't cover all the different discussions that we did on it. So this is an update to the arc length homework that I gave you before. Okay, so what do we want to do today? We are still going to be in section 10.2, and so let's recap what we have done last time. Last time we said that let's say we have a curve C, and the curve C is given by, let's say the curve C is given by x is x of t, and y is y of t, and t is in a finite interval, closed and bounded interval from A to B. And so this, you can view this x of t and y of t function. These two functions are tracing out certain points in the plane, xy plane, and those points are called the curve, and it's called a parametric curve. And last time we learned how we can find the length of that curve. So let's say that the curve looks like this, and the question is, what's the length of that curve? And what we came up with is that the length of the curve is given by the integral from A to B. And what would be the integrand? The integrand is the root of what? You take the derivative of each component function, right? So you take x prime of t squared, y prime of t squared, and dt. Right, that's the length formula that we came up with last time. And we did some examples. What I want to point out here today first is that, what if the curve is not given parametrically? Maybe the curve is the graph of a function of one variable. Like let's say, let's look at the following. Let's let C be the graph of the function f of x, and let's say x is between a and b. X is between a and b. So now we have a function of one variable, f of x, and the graph of f of x, let's say f of x is like sine of x, right? Or x squared. So now in this case, what we have is a function of one variable and its graph, and let's say the graph looks like the following. So this is the graph of f of x, and x is going to vary from a to b, right? And so in this case, how do I find the length of this curve? Anyone has any idea? How do I find the length of this curve? This curve is not given parametrically, right? I don't have a parameter t, right? And I don't have x is x of t, y is y of t. So it's not given parametrically. So how do I find the length of this curve? Well, remember I pointed out before that if I have a function of one variable f of x, I can express this curve parametrically as well. So how do I express it parametrically? So C can be expressed. Anyone remembers how we expressed it parametrically? C could be expressed parametrically like what? Well, you could take x to be just t, okay? You can take y to be what? If I pick x to be t, right? What should be y? F of t, it has to be f of t, right? And then t is between a and b, because x is equal to t, right? So x is between a and b, so t has to be between a and b as well. So now I have expressed the curve parametrically, and now I know how to find the length, right? So what's the length formula? So the length in this case would be what? The integral from where to where? A to b. And then what's the integrand? Yeah, remember it's the root. It's the root, and then what's the formula we have? It's x prime of t squared, y prime of t squared, right? Okay, what is x prime of t in this case? 1. 1 squared is 1. What is y prime of t in this case? Y prime of t is just f prime of t, right? So I get f prime of t, but I have to square that, dt. Notice that the integral that I have now, it is the same if I write the integral from a to b of 1 plus f prime of x squared dx, because x, I'm replacing t by x, right? So the integral wouldn't change. Am I making sense? You know, it's like if I have the integral of t squared, right? What is it the same as, say, 0 to 1? Is it the same as the other one? Yes. So my point is, I can think of this now as a formula here. So if I have the graph of a function of x over a finite interval, then the length of that curve is given by this formula here. Everybody's okay with that? All right, so let's use this formula and come up with lengths of certain graphs. So let's say I have the following example. Let's say I have the function y is f of x, and f of x is given by 1/6 x cubed plus a half x to the negative 1, and x is between 1 and 3. X is between 1 and 3. And the question is, what's the length of the graph of this function? Okay. So let C be the graph of this function, and the question is, what's the length of C? So the length length of C, well, what is my formula? Okay, integral 1 to 3 and what? Square root of 1 okay, so you're taking the derivative of f prime of x, right? So what is f prime of x? Can someone tell me what is f prime of x? Well, what Enia is saying that f prime of x is what? You take the derivative of f, what do you get? 1/6 3x squared, right? Which is half x squared. And then you take derivative of half x to the negative 1, right? So it'll be half negative 1 x to the negative 2, right? Everybody's okay with that? And then that becomes negative half x to the negative 2, right? So the derivative f prime of x is then comes out to be 1 to 3 1 plus f prime what is that? This would be 1/2 x squared minus 1/2 x to the negative 2, and then we have to square that dx. Everybody is okay so far? Now what do we have to do? If we want to integrate this, one way to do that is to see if we can get rid of this square, the root. And if I want to do that, I have to complete square inside. Now in order to do that, we have to first of all multiply out. So let's look at the quantity 1 plus half x squared minus half x to the negative 2 squared. And if we expand this, what do we get? Do we get 1/4 x to the 4 minus a quarter plus 1/4 x to the 4, x to the negative 4? You guys agree with that? Oh, this is not 1/4, I'm sorry. This should be a 2 here. This should be a 2. This should be a 2. Everybody's okay with that. If you expand it, that's what you get. Now, what is 1 minus a half? So that's going to be 1/4 x to the 4 plus a half, because 1 minus a half is a half, and then plus 1/4 x to the negative 4. Everybody is okay with that? Everybody's okay? Now how do I make it a square? How do I make it a square? Well, there are a couple of different ways. One is if you remember how to use this formula here. Let's say if I have a squared plus 2ab plus b squared, what is that? That's a plus b squared, right? A plus b squared. So then I could what I could do here is that I could say this is 1/2 x squared squared plus 2 times half x squared half x to the negative 2 plus half x squared squared. You guys agree with that? Half x to the negative 2, sorry, negative 2 here. Because in the middle term is still just 2, right? Because when you multiply, the middle term is still half, because 2 and 2 cancels out, and then x to the 2, x to the negative 2 gives you x to the 0. So, but if you think about now this guy to be a, okay, if you think about this to be a here, and this to be b here, then it is a squared plus 2ab plus b squared. And so you can complete the square and say that this is a plus b squared. So half x squared plus half x to the negative 2 squared. Is that making sense to you? Now there is another way of going about this, which is the following. So I'm just redoing it, okay? This is just redoing from this step here. So redo from this step in a different way. So what I'm going to do here is that I am going to factor out a quarter and x to the negative 4. Okay? So if I factor out x to the negative 4, and if I factor out 1/4, right, what do we get? What do we get if I factor that out? I'm going to get actually what here? Was that? Yeah, because I'm factoring out actually negative 4, right? So when you factor out something, you divide, right? So you divide x to the 4 by x to the negative 4, right? X to the 4 divided by x to the negative 4, and then you have to subtract the exponents, right? And then you get 4 minus a 4 minus a minus 4, which is 4 plus 4. Is that making sense? So if I factor out x to the negative 4 here, so I have to divide this guy by x to the negative 4. And if I do that, I get x to the 8. So I get x to the 8 here. And then in the middle term, what do I get? Middle term, I would be getting what? Am I getting 2 times x to the 4? Because I'm factoring out a quarter, I have a half there, right? So I need a 2. And then, well, notice that if I multiply out 2x to the 4 with this guy, I get exactly half, right? Is that making sense? Again, you're dividing, right? You're dividing half by 1/4 x to the negative 4, right? You are dividing half by 1/4 x to the negative 4, right? So when you divide like this, what do you get? This is going to become half x to the 4 over a quarter, right? And then half over a quarter is what? 2. Okay? So I get 2x to the 4, and the last one is what? Last one is clearly 1, right? So then, notice that what I get is 1/4 x to the negative 4. Can you factor out now what I have inside? Okay, the way you want to view what you have inside is you have x to the 4 squared, right? Plus 2x to the 4 plus a 1. So if you view this way, right, then this is 1/4 x to the negative 4. How do you factor this out? Well, if you're not sure yet, replace x to the 4 by replace x to the 4 by y. So you get y squared plus 2y. I don't want to use the same y, sorry. 2y plus a 1. So here y is x to the 4. And then you can factor that out now. Is it clear? What is that? It's y plus 1 squared, right? And then this would be 1/4, actually negative 4, and y plus 1 squared, y is actually 4, so this would be actually 4 plus 1 squared, right? Am I making sense? So notice altogether, this is what then? This is a half, actually negative 2, multiplied with actually 4 plus 1, and then I can take the square of the whole thing, right? So that's how I can square the whole thing. This way as well. Which way is better? Well, for me, I have that formula a squared plus 2ab plus b squared in my head, so I just quickly use that, okay? But if you are not comfortable with that, then you could factor out 1/4, actually negative 4, and then factor out after that. Is that making sense? All right, so either way you can complete the square. So I'm going to go ahead and use this. So what I have then is the length is the integral. Remember, it was from 1 to 3, and then the square root. And what we obtained here is, well, we had 1 plus half x squared, and then minus a half, actually negative 2. So this is what we had, and then we completed the square, and what we obtained was 1 to 3, and here we got actually half, actually 2, plus half, actually negative 2. We got the square of that inside. So that's what we had right here. And then the square root goes away. I have half x squared plus half, actually negative 2 only. And now what's the antiderivative? What's the what's that? Drawing dt? Well, you're integrating, right? Oh, yes, thank you. Thank you. It's just, I still have in mind t. Okay. So, yeah, you're right. So this is going to be dx. Have I done that before too? In my previous steps, did I do that? Okay, I had dx before. Okay, so then what is this? This is half integral of x squared dx plus a half integral of actually negative 2 dx, 1 up to 3, and then I have half, and what is that? Actually 3 over 3 between 3 and 1 plus a half. And what is the what is the antiderivative of actually negative 2? Negative actually negative 1 or 1 over x. So 3 and 1. Okay, and what do I get here? I get half times, if I plug in 3, I get 3 cubed over 9 over 3, so that's 27 over 3, which is 9. And if I plug in 1, I get a 1/3. Here, here I can say this is negative half and 1 over x between 3 and 1. And so this would be half 9 minus a third. This is half, this would be what? 1/3 minus a 1. Everybody is okay with that. And I'll let you simplify after that, okay? Any questions on any of the steps? Yeah?
Yeah. Did you scroll up when you're completing the square?
Yeah.
You said under your first step.
You're talking about right here? Okay.
Right here.
Yeah.
What happened to the 1 there? You have 1 plus.
Oh, one and a negative half were combined to give you a positive half.
Oh, okay.
Yes. Any other questions? Back down, okay. Here? To the bottom, okay. Okay, you're trying to write down. Any other questions, anyone? Okay, I will do one more example. Let me know if you're done writing it down. And I'll just finish by doing another example. The difficulty in these problems is usually that step where you try to get rid of the root, right? So, make sure you look at my video if you're still not sure how you complete the square. If you understand how to complete the square, these problems are pretty easy, right? You just set up the integral, and then it's just computing the integral. Usually these integrals are straightforward integrals as long as you can get rid of that root. Okay? Because after that it's just integrating powers of x, right? So usually the problems are like this. Now, sometimes when I ask questions from this section on arc length, I also sort of try to ask like two separate parts. So in one part, I give you a function where the integrand is really hard. So what I say, set up the integral to find the arc length. But when I say set up, I mean that you don't compute the integral, right? Am I making sense? And then I ask a separate question where I say compute the arc length, and in that case you have to compute the integral, but I try to make the second part so that the integral becomes easy. Okay? All right, so now sometimes what happens is that the curve C is not a function of x, so it looks like the following. Let's say you have the following curve. Let's say now you have the following curve which looks like this. Now, this is certainly not a function of x, right? Why is this not a function of x? Yeah, it doesn't satisfy the vertical line test. So let's say I have the, let's say I have, this is C and this is D here, but I can view this as a function of y, right? Notice that I can view x as a function of y though. Is that making sense? So when that happens, how do I find the length? Well, in this case the length is exactly the same. You go from C to D, and 1 plus, and now it's g prime of y, squared, and then you have dy. Everybody's okay with that? So let's look at an example involving y. So let's look at the following example. let's say I have x is you know what, let me first say the following. Let's say the question is set up an integral to find the length of the curve which is given by let's say I'm going to call the C, length of C, where C is given by let's say x is y squared and let's see, x between -1 and 1, okay? Sorry, not x, y is between -1 and 1. Everybody's okay with that? Anyone remembers what's the graph of this curve? Yes, so let me try to draw this. So it's going to be something like this. So here's, let's say, here's, let's say, +1. Here's, let's say, -1. So y is between +1 and -1, right? And we want to find the length of that curve. Is that making sense? And this is not a function of x. So how do I find the length? So what's the length then? What's the length? It will be integral from where to where? Whoops. -1 to 1. And then what do I have inside? It's going to be 1 plus. It will be what? 2y squared, yes. 2y squared, which is equal to what you said. 2y squared dy. And so what we get is it's -1 to 1, 1 plus 4y squared. Anyone knows why I said set up? Because I didn't want to do the work, right? The reason is this integral something that I can compute? And if I can, how? Yeah. Yeah, it is a trig substitution. It is like having root of 1 plus x squared, right? And if I have root of a squared plus x squared, what's the substitution? Tangent, right? A tangent theta, right? So I could do that substitution, but it's long. I'm not going to be able to finish it. So that's why I said set up, okay? So, any questions on this? Everybody's okay? All right. So I am not done yet with 10.2. I want to do a few more examples tomorrow, and then start section 10.3. Now, those of you who are going to take Calc 3, these ideas in Chapter 10 are important for you, okay? So you're going to need it right away when you go there. So keep that in mind. I am going to give you your exam back right now, so I'm going to stop right here, okay? Any questions, anybody?